All right, so finance is not on the next quiz, it's on the quiz after that. Quick review of things you should be able to do. Kind of feel like we might have done these. Ooh, maybe not. Oh, what is that mess? Well, let's talk about this one for a second. This means 36 to some power equals the 5th root of 6. Could we rewrite that? 6 to the 1/5. Okay, can we make this a base of 6? That is 6 squared to the something. And how do you, what's the relationship there? You multiply. So 2 times something is 1/5, right? This has to equal this because they're both the same base. Everybody okay? How do you get rid of times 2? Take half? Will that work on this one? 1/10? That would be 0.2 if you did it as a, no, it would be 0.1. Just kidding. 1/10 is 0.1, not 0.2. Don't listen to me. All right, how would we rewrite this? 4 to the 4, wait a minute. Oh, 4 to the 1/7 is raised to some power and becomes 64. Did I do that right? Okay, now what? Can I make that a power of 4? Yes. 4 to the 1/7, and we already discussed that those would be multiplied, right? Times something equals 4 to the 3rd. So this exponent has to equal this one. So we have 1/7 times something equals 3. What?
21.
Yep. So we're going to multiply by the reciprocal.
Wasn't too bad.
Okay. I'm pretty much 100% positive neither one of those are on the quiz. They're not quite that tricky. But it was a good warm-up.
Wasn't too bad.
All right.
We've had worse.
In lesson 3.1, we talked about compound interest, and that was a pretty complicated formula. It had a lot of variables, right? But it's on your reference sheet. Okay, when an investor takes out, for example, an annuity is when you're going to make, say, I start a 403B, and I'm going to put in $100 out of every paycheck, and it's going to grow in this account until I retire. Does everybody get what an annuity is? It's when you're making regular payments into it, into some kind of a savings. So it's hard to calculate how much money is in there because every month they add some more in. Okay? So this is the formula. One of the pre-calc teachers used to make the students do this and learn to do this on their calculator before she would show them the finance app. Can you imagine how many sets of parentheses you need to make this lovely formula work?
At least 5.
Yeah, I think a lot. Okay? Can we go with, there's an app that does that? There's an app for that? Isn't that a commercial or something? There's an app for that? So this is the formula for future value. There is also, I'll show you one more formula somewhere here. This one is to figure out how, if you are making a payment, how much you have borrowed and what your payment would be, what your monthly payment would be.
Wait a minute. Isn't the PMT part of the other equation?
Yes, it is because, no, wait a minute. This is a payment into an account. This is if I'm putting $100 in. The other one is if you borrow money for your car, how much will your payment be? Okay? Anyway, they're very complicated formulas. That's all I wanted you to see. You don't have to memorize them or even use them. Okay, because solving this equation by hand can be tedious, to say the least, you can use the finance application on a TI-84. It is called the Time Value of Money Solver, TVM Solver, and I can never for the life of me remember those letters in the right order, so I'll call it everything wrong. But what you want to go to is the apps button, which is next to math. And it is the very first one. It comes installed on all the calculators, even the older ones. Yes? Okay. Everybody find it? And then you just hit enter. And then inside of there, it will let you do a whole bunch of different things. But best of all, it just has a solver. So we're going to pick that number 1. Now, you might have a bunch of numbers in here because if you've ever used it on the calculator, it stores the values you used last time in there. But we're going to go through what these things mean. But just watch me for 1 second here, okay? If I was going to make, let's see, N is number of payments. So let's say I was going to teach for 5 more years. So that would be 60 payments, right? 60 months in 5 years. And we'll say my retirement account was going to earn me 5% interest. And it presently has nothing in it. But I am going to make, I could probably swing to, maybe even more a month. You know what? Let's pretend I'm getting back child support. And we'll put $400 in there for my payment into my retirement account. All right, so I want to know what my future value would be at the end of 60 months. And I'm going to say I'm making 12 payments a year, and it is being compounded monthly. Then what I get to do is I put my cursor on this future value. And down here, did you ever wonder what this green solve was for by the enter? Like, hey, I want it to solve something for me. Well, this is the first time it's going to solve something. Wherever you put your cursor, this is the fun part of a solver. Wherever you put your cursor and then you hit alpha enter, it will solve for that value. Now, let's talk about why it's negative. Okay, because if the money going into my account was positive, then the money coming back to me has to be negative. There has to be a sign change. I could put this in as a negative. Let me go back up and show you. I could have put, I'm going to put in $400 here. And then when I did alpha solve here, I get the same value, but it's positive. Does that make sense?
The money that you're taking out of your pocket.
Yes. You can decide which. I usually don't bother to put the negatives in. I just, when it comes up as a negative answer, I ignore the negative because I know one way is going into the account, one way is coming out. Okay. Your money leaving your hands, your money coming back. So just know that they have to have opposite signs. It doesn't matter which way you put it in. So this is a pretty good deal. I could put away $27,000. Okay. Now think for a minute. How much money did I actually put in there though? Do you remember what we said? 60 payments of $400. So I put in $24,000 of my own money, but it made $3,500 in something, right? Wasn't it? It made interest. Okay. So that's how that works. That was just a quick example. Let's go back to the notes. So it is called the Time Value of Money Solver. And let's go through what these things mean. Do you have your reference sheet? Because they're listed at the bottom of the reference sheet. You're welcome to write on there because I'm going to give you a new one the day of the quiz. It's gold. Does everyone have one? It's in the back if you don't have one.
What? Is it this thing?
Yeah.
Okay.
It has the formulas for chapter 3. But down at the bottom, it says this. N is the number of, does yours say payment periods or what does it say? Okay. It is, that also could mean the number of payments you make into something, okay? I is the interest, and you have to put it in as a percent, not a decimal. Is everybody listening? Don't move the decimal over, okay? You put it in as a percent. That's why it says I% on your screen. P is present value. Payment is how much payments you're making in or how much your payment will be. Future value is FV. Now, think about this a minute. If you borrow $1,000 and you want to know what your payment's going to be, what is your future value at the end of your loan what you want it to be? 0, okay? So usually either your present value or your future value is 0, not always, okay? Payments per year and compoundings per year. Generally, those are the same, okay? Generally, we're going to leave those the same. Most of the questions we do, we're going to leave compoundings per year at 12 monthly interest, okay? And we're going to leave this, the bottom has like, are you doing it at the end of the month and then they're going to compound it, or is it the beginning of the month? The default is end, and we're going to all leave it at end. If it doesn't have end, you're going to get different answers, okay? All right, moving on. An investor, ready? This is an example. Do you have this one or not? I'm on 4A, I think. An investor pays $600 quarterly into an annuity. Okay? I don't know, it might be done for you, but he's making, the payment is $600, so that goes here. I could make it negative 600, but I'm not going to bother. But he's only doing this quarterly. Rather than having it, maybe they charge him. Some places they take a fee every time you have to deal with them. So he's going to save up his money and only put it in 4 times a year. So his payments per year are going to be 4. Into an annuity, the annuity earns 7.24% annual interest. So up here we put 7.24. We don't move the decimal over. What will be the value of the annuity after 15 years? So the number of times it's going to compound here and the number of payments he's going to make is he's going to make 4 payments a year for 15 years. Guess what? We can type in 4 times 15 there and it'll do it. It's 60, but you don't have, if it's something complicated like monthly payments for 27 years or something, you can just type 12 times 27 right there. You don't have to go back to the home screen to do it. All right, so the present value is starting with nothing in there, and we want to figure out how much he's going to have in there. So this is where we're going to put our little box and solve. Now, compoundings per year. This doesn't make this clear. I'm going to go with 12. Does yours say something on it, on your sheet? Okay, well, we'll see what happens. Yeah, it does say 4. Right here it says they made it the same. Compoundings. So they're going to compound it every time he puts his money in. So they're saying this is 4. We don't, in most all of our examples will be 12 and 12, but this one is 4. Okay. So we want to calculate how much his future value is B. So here's my calculator. See if I can slide this over. I need to go apps, enter, enter. We said 4 times 15 years, 4 times a year, 60. But as soon as you move off of that, it'll change it to a 60. But it's nice that you can just type in 4 times 15. Was this 7.24? Present value is nothing. He's putting in payments. How much were they, guys? 600. And this we decided should be 4 and 4 instead of 12 and 12. So future value is what we want to find. Now mine has a number there because that's from the last question. Okay. How do you solve again, guys? Alpha and enter. $64,102.91. Anybody? Okay, let's go to the next slide and make sure that's what they got. Yes, okay, so after 15 years, the value of the annuity will be $64,000, about $103. Now, it's negative because that's how much is going to come back to him. It's just me, one time he was giving it over, once he's getting it back. You don't put down his value is negative $164,000, okay? When taking out a loan for a large purchase like a home or a car, they're concerned about how much your monthly payment will be. I mean, that's where I started. When I wanted to buy a house, I figured out what could I afford to pay for a month. And then I figured out backwards how much I could afford to borrow and look for a house in what price range, okay? So it says, this one is working the other direction. You borrowed $170,000 you're planning to borrow from the bank to purchase a home. The 30-year loan has an annual interest rate of 4.5%. Calculate your monthly payment and the total amount paid after 30 years. This is all about adulting, guys. You're going to get an eye-opening experience here. All right. Where does the $170,000 go?
TV.
Yes, it is our present value. We are borrowing that. You could put it in as a negative if you want. Just it means you'll get a positive answer instead of a negative outcome. You want to borrow it for 30 years. So how many payments are we going to make?
12 times.
Yes, because we're going to make monthly payments for 30 years. The interest is 4.5. What are we trying to find here?
So the future value is negative.
Yes. At the end, we're going to, at the end of 30 years, we want this loan to be paid off. We're trying to find the payment, so that's where our little box goes. And it's going to be 12 and 12 because they didn't specify otherwise. So we're doing monthly payments and we'll do monthly compoundings. Okay. So 12 times 30 or 360, isn't it? Okay. This was what? I already forgot. 4.5, which is actually, I think, not outrageous from what they're charging right now. Could be higher even than that today, I'm not sure. 170,000. The payment is what we want to figure out, but we got to change that future value to 0 so that we pay off our loan. And these are 12 and 12. All right, so what is our payment going to be?
Very freedom.
861.37 or something? Now, notice I rounded. Anytime you borrow money, the very last payment is usually an odd amount. Because of all the rounding that's gone along the way, you'll be off by a few cents at the end. In order to pay off a loan, usually you have to get that last payment amount from the bank. And usually they're going to give you something back, like the title to your car or the deed to your house, whatever they have had in their possession in order to make you pay the loan. Does that make sense? All right. So that was our monthly payment. How do we figure out the total paid after 30 years? I don't know why students have so much trouble with this. Nope. We made this many payments every month we made this much of a payment. I didn't say that right. Every month, which would be 12, right? For 30 years. So you could just multiply by 360 if you wanted. But what is that magical number? 861.37 times 360. 310. 093 and 20 cents. Okay. How much did we borrow for this house? $170,000.
And 20, yeah,
We almost paid twice for the house, right? That's real world, guys. That's the way it works.
get a career in banking.
Okay? Your parents will vouch for this, that by the time you pay off. Now, do you want to see what happened? Let's have a life moment here. Change it to, I'm going to pay off, my loan in 20 years. I just want to show you what happens. So we're going to change, it's going to change the payment quite a bit. But go up here and change N to 24 times 12. Leave everything else the same. Go down to your payment. Now, did it change your payment by a huge amount? Not really that much, right? Now it's $966.32. Did someone else get that number? Oh, what did I just do? Okay, if we went with 20 years, it was $966.22. That's almost only $105 difference, right? So if you could fork over an extra $105 a month, you could pay your house off in, yes, 10 years faster.
How much less in
And how much less in interest? How would we figure that out?
times when
12 times 20, right? 20, yeah, 12 times 20, right? Monthly payments for 20 years was what we planned. 966.22 times 240 is, you'd only pay $231,382.80.
that's
What did I do?
You put 24 and 24 years.
24 years was the weird number I made up?
Yeah, or the N you put.
Oh,
24 would be.
Okay,
27,000.
24 years. What is it? 278?
Yeah, 1,000.
Okay. I don't know where I came up with a 24. Anyway, usually it's a 20-year or a 25-year or a 30-year mortgage. I don't know where my brain was. But even taking 6 years off, right? And $105 more a month. Yeah, you saved like $40,000 in interest or $35,000 in interest.
started bank is gonna be.
All right, I'm gonna get all this off here because I just made a mess anyway. Maybe we'll try that on another question, but these are all future value of the annuity. This is your homework. It's actually not 1 through 13 odds because I think that you don't have to do 11 or something if you look on the homework checklist. Do you want to do one more of these? Because we have only did one annuity question. Pick one. Number 5, okay. How would you put this? I'm going to write down what you would put in. You can put it in later or now, it doesn't matter.
So is this
Yes, this is a homework question. Number 5. Quarterly, right? Quarterly for 8 years. So N would be 4 times 8 or 32. Everybody good? Where that came from? And then I is just 5.5. And then what's next? I get messed up. PV? Present value. Okay, if it's in a retirement account, you're starting with nothing. Okay? And then is it payment? Okay, and how much are we going to put in? $450 it says. And then future value is what we want to find, right? And compoundings per year and payments per year for this particular one. Quarterly, so we're going to go 4 and 4, yep. All right, anybody typing? What'd you get? 17.50. Okay, so if we put away 400, if I'm your mom, okay? I want to save for you for college. I'm going to put away $450 every quarter for the next 8 years, starting, maybe I started when you were 10, okay? That means this is what you would have had, $17,000 for college. An annuity doesn't have to be a retirement. It can be for whatever, but you're saving up for some future thing by putting away money regularly. No, that is the total future value. If you want to figure out how much of it is interest, Cameron, can anybody help us think about that? What would we do? we made how many payments? Yeah, we did 32 payments, right? Of 450. Anybody figure that out? That'd be 900 times 16 or 1800 times 8. Yeah, I'm not getting there. 3600 times 4, 7200. 14,400? Oh my goodness, I actually multiplied that. Okay, so me putting the money away in an annuity earned you an extra $3,500. Okay? So 14,000 of it was my money that I put in there for you, but there was a lot of interest earned as well. Okay? All right, that was number 5. The second part of the assignment is to do 7, 9, and 13, I think. Okay. You want to do 13? 13 is the kind of fun one that's about adulting. Do 13 together? Okay. Changing a value of any of the variables may drastically affect the loan payments. The monthly payment for a 30-year loan for $150,000 at 6% interest is $899.33, with a total payments of $323,757.28. Calculate the monthly payment and the total of the loan for each of these scenarios. Okay, what if you put $20,000 down before you took out the loan? So instead of borrowing $150,000, we're going to put 20% down. What is 20%? 0.20 times 150,000, guys. We're putting, oh, it doesn't say 20%. Thank you. OMG. Yeah. It says we're going to put down $20,000. So I think we can figure that out without a calculator. How much are we going to borrow? So we're, oh my gosh, someone make me read. Okay, we're going to borrow only 130,000. So what's that going to change? Okay, let's get our calculator going. We are at the app, and how do I make that better? There we go. How long we borrowing this for? Still 30 years? Is that what it said?
30 years.
Times monthly payments, so 30 times 12. What was the interest rate? Given in the question, 6. Okay. Our present value is what we're borrowing, and what did we decide it was going to be? 130, because we put $20,000 down. Okay. Our payment is going to change. Our future value is going to be 0, and these are still 12 and 12. Can you figure out what the payment would change to?
7.
That's what I got. $779. Okay. So calculate the monthly payment. The monthly payment would be down to, what did I just have? 7. Okay. And the total amount for each scenario. So what are we going to multiply 779.42 by? To figure out the total of this loan. Yes, 30 years of monthly payments. So 779.42 times 30 years of monthly payments means we would have paid a total of $280,591.20. Okay, so by putting down $20,000, how much interest did we save from here, guys? $44,000 almost? Is that right? Or is it 100 and, no, it's 44,000, okay? So by putting 20,000 down, we saved 44,000 in interest. And our payments went down how much? Do you see the difference there in payments? $120 a month, right? Okay, so if you can get your mom and dad to, give you a big down payment for your wedding presents or something.
I don't think that's.
That didn't happen in my life, no. All right, what if it said the interest is 4% instead of 6%? So we're gonna go back to the original problem. We're not putting any money down, so our original loan is still, what, $150? So we're still borrowing $150, but this time the interest is what? Only 4%? So let's see what that does to our payment and to our total that we have to pay. Our payment goes down to $716.12. Anybody? Yes, no? Okay, the payment goes down to that. So from $899, that was great, right? This was our original payment up here. And then what? How do we figure out the total? Yeah, go to the home screen and do 716.12 times 360. 257. $803 roughly. So interest rate makes a huge difference. Do you see that, guys? It was originally we had to pay 6%, and it went down to 4%. That what saved us $183 a month in our payment, and it saved us a total of, I don't know, 323 minus 257, like $66,000 in interest. All right, what if we went and decided we're going to pay it off in 20 years? That's going to make our payment a lot more, but we'll save a lot of interest. Okay, we're going to go back and put in 6% interest again. We're still borrowing $150, but what changes? How do we change it to 20 years? Yes, this would be 20 times 12 up here. And then what would our payment be? Yeah, heftier payment for sure. But I bet a lot of your parents probably pay a mortgage payment that is close to that amount. Thank you. And then what are we going to multiply that by? Be careful. Yeah, only 240 this time because we made it. So while our payment went up a lot, the total we paid should have gone down. Actually, it's very close to the last one, right? So even though our interest was 6%, we still paid roughly the same as we would have at 4%, except we paid it off in 20 years. You want your payment to be as much as you can possibly swing, because it'll help you in the end. All right, this is the one that floors me, that it makes such a difference. Go back to the original numbers. So we're going to go 30 years. But we're going to make 13 payments a year. So I think we're going to do times 13. Okay. And we're leaving this 6 and 150,000. But our payments per year is going to be 13. But you don't want your compoundings per year to change. We're going to leave that at 12, which you have to override, I think. I think that's how you do that. We're going to go for it. The payment would change to $829.99. Okay. I feel like that's wrong. Oh, I know why it's wrong. Because we don't want to change anything. I think what we're supposed to do is figure out how many years it would take to pay it off. We're gonna keep everything what it was. What was the payment in the book, guys? $899.33. $899.33. But we're gonna make 13 payments a year. And we're gonna go back up here and figure out how long till we pay it off.
How many months?
So if we do,
I thought that was years.
whoops, alpha solve, we get 124, right? Yes, so if we made an extra payment of $899.33 every year,
So it'd be about 124 months. Sorry?
what did it say, 124? Okay, divide that by 12, and you'd pay off your house in 10.3 years? No, something's wrong. I think we maybe are supposed to leave this at 12. That wouldn't make any sense.
Yeah, because it should be 13. Maybe it's still
Well, you
13
did say that it
compound?
made a really big difference.
Is it 13 compounds on
No, because you're paying it off 13 times a month.
Yeah, this should be. Is that what it was originally? 30? No. Wasn't it originally 30 times 12? And this is what they told us the payment was?
Maybe it's because we didn't put the payment as a negative?
Maybe? If I
But no, that. it
If I
made the
change
number-
this to 13, and I go back up here,
No, right. You got the compound.
compounds 13 as well.
oh, all right, I don't think that's gonna make much difference. Well, it might, but,
318 now. In my compound.
yeah, I still think that's not gonna make a big difference. Okay, 318.9, so, go back to the home screen. 319, we'll round it to, divided by monthly payments is 26 years instead of 30 years. You'll pay your house off 3.5 years sooner by just making one extra payment a year. Phew, that was painful. Okay,
It was. So that's
which
the-
saved the most money? Which had the lowest payments? The lowest payment was the interest? Lowest interest?
So,
And I think the lowest interest, oh, I guess paying it off in 20 years actually was the lowest. Okay. All right, we got 5 minutes left. Okay, we're gonna look at the back of the worksheet real quick. And then we're just gonna continue on tomorrow, so don't panic that we're not finishing what I thought we were gonna get to today. It's all right. This is a simple interest question. Anybody have the formula sheet in front of them? Because simple interest is just what? I equals PRT. But be careful, that's not the future value, that's just I, the interest. So this would be like you borrowed 4% from your uncle at 0.062, because you're gonna move the decimal twice, for 8 years. That's what he said, I'm gonna charge you 6.2% interest because that's the going rate. But he's not gonna compound your interest like the bank would. He just said after 8 years, I want my money back. All right, I got 1984. Did anyone else get that? It was a good year. I was a sophomore in college. Okay, but what we actually owe our uncle back is also it says find the total value, find the interest. This was the interest.
Uncle, you're taking like almost half of the whole.
Well, okay, but we owe him a total of 59? I can't add. 59.84. Okay. If he had compounded the interest, it would have been a lot more. Okay. Number 2 says find the total value in investment if it's compounded monthly for 8 years. This is just, we put $4,000 straight in. We don't need the app, guys. 1 plus, remember this? 0.062 compounded monthly means we divide by 12 for 8 times 12 years. Compound interest, you don't need the app. You can use the app, but it becomes confusing because you have to trick it into doing some things. Because you're not making payments. I got 65, 60, and 18 cents. Anyone else get that? Okay, we're gonna do one more question with the app, okay? Did you get 65?
Yeah, I forgot to parentheses.
Okay.
So
Let's do number 4. 5 years from now, you'd like to have $10,000 to pay for a trip around the world. Your investment company says you should be able to earn 5.5% interest monthly. Okay, so how long are we gonna put this in there? We're putting in presently, no, our future value, we wanna have $10,000. Is that what that says? Okay, we're gonna earn 5.5% interest. Our present value is nothing. How much money, oh, it says how much money would you need to invest today? So our present value is what we're trying to find. We're not gonna add to it. We're just gonna throw a bunch in there now. So we're not gonna make payments. And it's compounded monthly, so I'm gonna put 12 here. We're actually not making payments, but I don't think it matters because our payment says 0. And how long till our trip? So I think we put it in as 5 times 12. Try that real quick. Even though we're making $0 payments, I think that's how you have to put it in. 5 times 12, 5.5. Present value, payment is 0. Future value, I want to have $10,000. So my present value that I need to start my account with, okay. $7,600. Anybody getting that? $7,600.50. If I put that in the bank today and don't make any payments, would grow to $10,000, so I can go on my round the world trip. All right. Tomorrow we'll finish the notes, but tonight finish that bookwork on page 171. I didn't leave you very many questions.
Can we wait the donate?
Girl, you haven't even started.
I don't want to start. Or how about